Hey, I'm Adam Kelly. In this tutorial, I'm going to show you how to make pigs that can intelligently find truffles with Unity's ML Agents project. Unity's ML Agents toolkit is a GitHub repo that has a bunch of awesome tools for using TensorFlow and training little agents to do different tasks. So they have a bunch of examples here, and one balances a ball on this little board, and another one plays soccer, another one pushes a cube to a target. So we're going to use this to train our pigs. By the end of this tutorial, you'll have pigs that are actually fairly good at picking up truffles. They'll start out not looking so good and gradually improve, and you'll start to see that they look like they actually are intentionally moving around within the area and picking up the truffles. Rather than begin by taking you through a setup process that would probably be out of date within a couple of months based on the cadence that they're releasing this ML Agents project, I figured I would just point you to the Unity documentation for this, which is very thorough and well written and very good. So if you go to the Unity Technologies GitHub page, their ML Agents project, under Docs, Installation, their documentation right here is excellent. It'll teach you how to download Unity. It'll teach you how to set up on Windows or Mac or Unix. And then at the bottom, once you've followed all these steps, don't skip anything in here, the basic guide will get you started with the fundamentals of actually running these sample projects. So this sample project is what they walk you through, and that will make sure that your system is set up properly and we can get into actually making our own project here. Let's start a new project. So go to New. We're going to create a new project. I'm going to call this one Pig ML Agents, but you can call it whatever you want. Create project. While this is going, I want to point out I have this folder on the side. I called it Pig Project, doesn't matter. This isn't anything special. I just put a bunch of stuff that I was going to need. So I will post links to all of this in the YouTube description, but also on my website. You may have to go to the website to get everything. Under meshes, I have several different meshes that we'll use in the project. Under ML Agents, this is actually just a release of the ML Agents project that I downloaded from the GitHub page. And then the TF Sharp plugin is the TensorFlow Sharp plugin that we need for this project. So we need to import all of this stuff, not all of it, parts of this stuff into our project. So what I'll do, I'll drag this over to the side so we can see what we're doing. And I'm going to first pull in the meshes because that's pretty straightforward. Just drag it into your assets folder. And those should now be in here. If you look, we've got a little piggy. Then if we go back up to assets, we want to do ML Agents inside the Unity SDK folder. Under assets, we just want to get this gizmos and ML Agents, and we want to drag both of those down into assets as well. This one takes a tiny bit longer. That's just all the foundational things. If you go up to this larger project, it's not letting me click there right now, but if you go to this larger project, you'll see there's a lot of other folders and stuff. That's not necessarily required for creating a new project. Just these two folders are. And then the last thing is this TF Sharp plugin. We can drag that in too, and the reason I did this last was because otherwise it'll create a duplicate ML Agents folder. If we do it this way, it'll import it and it'll put it inside that same folder. So I'm going to drag this in as well. Okay. Now what will happen, I have to click here. It's actually ready. This TF Sharp plugin import thing got hidden behind the other window, but it's ready to import. All this stuff that's grayed out is already in there. But if you scroll down, you'll see what it's actually going to import. In this case, it's just importing all this plugin stuff that we need to run it. So we'll click import. Okay, so that's done. Now the last thing we need to do is go into edit, project settings, and I may have maximized this earlier. You can maximize it like that. You can go to player, and then if you scroll down under other settings, configuration, In 2018.3, that version of Unity, this scripting runtime version is automatically set to this new version. Apparently that just happened in this version. And then we have to edit this scripting defined symbols to include, in all caps, enable TensorFlow. And then we also have to allow unsafe code. When I didn't do this, I was getting error messages. And I checked in the code, and there is some unsafe flags that are in there. I don't really know what that means, but it doesn't seem to cause any problems for me so far. Now this should be ready to go. I'm going to close this out. We should be ready to start actually creating our scene. I want to help you envision what the scale of this project is going to be. So the first thing I want to do is just bring a pig into the scene. This pig is actually just a meter long. So that should give you an idea of what kind of scale we're working with. So I drag him into the scene. I can hit F to zoom in on him. We can see this cutie ready to find some truffles for us. We're going to turn this into a prefab. So I'm going to create a new folder, prefabs, and I'm just going to open that up and drag him down into it. So I want to create a new original prefab, not a variant. So I'll create this original prefab. This is new in 2018.3. So if you haven't seen this before, it's pretty cool. We created a new prefab, and now we can open this prefab, and we're editing the prefab in isolation. This is not in the rest of the scene. So anything we do to him is going to affect all of them in the scene. So that's pretty cool. So now we have a pig. I'm not going to attach anything else to him. Well, actually, I'll add a mesh collider to him right now. Mesh collider, and this, we actually want to grab the pig collider that I've included, and you can see that it creates this kind of rounded edge collider around the pig so that he doesn't get stuck on corners. And then we want the convex option, which makes it just a little bit simpler. So that's good. We can back out of this edit mode, I'll make this a little bigger, by clicking this tiny arrow, and now we're back into the main scene. In order to have space to move around and find these truffles, we're going to need another area, another prefab. I'm going to call this the pig area. So I'm going to create an empty game object for one, and I'm going to set the X, Y, and Z to 0, 0, 0, and I'll call this pig area. And in the pig area, actually, we can just start creating this as a prefab right away. So we can drag this empty thing down into here and call it, it's called pig area. Perfect. And because I'm very particular, I'm going to rename this to capital Pig. And I believe I can just delete him from it. Perfect. So now we have this pig area. We can click this little arrow here, open prefab asset, and now we're editing the prefab. So the first thing I'm going to do is create a floor. So I'm going to create it as a cube. I will call it floor. Well, I'll call it ground. And I want it to be 25 in the X and 25 in the Z. And then because it's 1 meter tall, I'm going to position it down by half of a meter. So now we have this floor. And if I drag in my pig prefab, this is a nested prefab. That's another cool new feature. You can see how much space this pig has to work with. So we're going to start with kind of a smaller area and then work into a bigger area eventually. And I can make changes to this pig. It'll reflect in here. This is a really great new system that Unity just released. So after the ground, we need to create the walls. So I will create another cube, and I'll call it wall. And we need to make it, position it a little differently. We need to position it out, I believe we can do 13, and that puts it right at the edge. Yep. And then in the Z and the, just the Z, we need to scale it by 25. Okay. And we're going to do the same thing. I'll just duplicate this, and we will position it at -13. Sorry about that, -13. And then I'm going to create another cube for the other direction of wall, which is the wall I'll call it wall 2 to stay within that naming convention. And we're going to set the Z position to 13 and the scale in the X to 25. And then I'll duplicate this one. And we will set the Z position to -13. Okay, now we have this. I actually wonder if this, oh, nope, that makes it worse. For some reason, it's a little darker inside the prefab view. I guess that's probably because there's no light source to see it. But you can kind of see what's going on here. So now we have this pig area. We've got 4 walls, and we've got a ground. Just to kind of give you an idea of what this will look like once we have it in the scene. I don't want to add this to the prefab right now. I actually, oh, isn't that nice lighting? I want to show you what the truffle will look like next to this pig and the stump. So the truffle is just this little black blob. And the stump, well, that's pretty big. Cool. So that will be an obstacle that the pig has to avoid. So these are things that are also going to be prefabs, so we might as well just make those right now. We're going to drag in the truffle. I'll create an original prefab. I'll open it up, and I'm just going to title it with a capital. You obviously don't need to do this. This is just me being very specific. So we're going to rename it. Yep. I don't know how important this is, but I'm going to set this to 0, 0, 0. And then we're going to do the same thing for the stump. We're going to drag this stump down into here and open the prefab, call it stump. Sure, rename the file. Reset that. And this one actually has a mesh collider. So we're going to add the mesh collider that I provided. Oops, not that one. This one. Stump collider. And you can see it's just kind of an octagon shape that I've created to go around it. Kind of gives it some space. He'll be able to walk over this root, but he won't be able to go through this stump. That's just kind of the goal. The truffle actually needs a collider as well. So if I back out of this, and then I actually am going to go into the truffle here and then add a collider here. And we're just going to use a cube collider. I think if we did a sphere collider, we would end up having it just roll around. So, sorry, a box collider. So we're just going to add a little box collider on that. Next, we're going to start actually doing something with the pig. So first, I'm going to clear these out of the scene, and I will save the scene. I'll actually save my project too. And then we're going to create a new folder called Brains. And inside this Brains folder, we're going to right-click, Create, and then you should see ML Agents up here at the top. We're going to create a player brain first. Now, just real quick, the difference between a learning brain, a player brain, and a heuristic brain, you can get all this in the documentation, but at a high level, a learning brain is one that's going to use deep learning and will be trained, and then will use that training to navigate the environment. A player brain is one that we can control with either the keyboard or any input. It could be an Xbox controller or whatever you want. And a heuristic brain is how you traditionally program a video game AI, as they call it, even though that's a very overloaded term. Heuristic is something like there's a stump there, navigate, one unit to the right and then 1 unit forward and then 1 unit to the left, and then proceed directly at the target, something like that. You would set up a list of rules. So we're going to do a player brain because the first thing we want to do is make sure that things are actually working properly. And we'll call this pig brain underscore player. And then if you look over here to the right, you'll see that there are brain parameters and discrete player actions. So on the player brain, what we need to do is we need to set up vector action branches for discrete movement. Now that sounded like gibberish. So vector action is basically a list of different actions that the agent can take. So this pig we're going to allow him to move forward, move backward, or just sit still, turn left, turn right, or just sit still. So the turn and the move are the two branches. So we need two branches. This first one is going to be moving forward, backward, or sitting still. So those are three options. And the same is turning left, turning right, or being still. So that's three options. So that's what those branches mean. Branch descriptions, the first one we're going to say is move, and the second one we're going to say is turn. Now down here, discrete player actions. Because this is a player brain and we're going to control it, we're going to do it with the keyboard. And we need 4 different discrete player actions. Okay, so we're going to use the W, A, S, and D keys, just like a lot of computer games that you might have played. And we're going to use those to control the different actions that you can do. So the first thing I'm going to do is, if you kind of get down to the bottom here and then you hit W, it should work. Branch index is 0. 0 meaning it's the first index in that branches list. And then the value of it we actually want for going forward to be 1, because the default is 0. 0 means don't move at all. Now, moving backwards, we're going to use S. So I'm setting this to S, and the same branch, but the value is going to be 2. So that means that we're going to get this list of values. And in the first slot, the value of 0 means don't move. The value of 1 means move forward, and the value of 2 means move backward. Now we're going to do the same thing with rotation. So moving left is going to be A. And this is the second branch, which is an index of 1. Remember, 0 is don't rotate at all. So we're going to set this to 1. And then the last one is D. And we will set this to a branch of 1 and a value of 2. Now it is time to start creating the academy. The academy is sort of this master script that orchestrates what's going on in our scene. So I'm going to create a new folder. I'm going to call it academy. Nope, sorry. I'm going to call it scripts. Inside here, I'm going to create a new script, new C# script, and I'm going to call it Pig Academy. And that's fine. We'll edit this in a minute. And then I'm going to add a new empty game object to the scene. I just right-clicked, create empty, and we're going to call this Academy. And now we have to open up this script, this Pig Academy. Now the important thing here is that we actually need this Pig Academy to inherit from Academy. And so I'm going to replace this with Academy and not any of these, just Academy. And then it doesn't like that, so I'm going to right-click Quick Actions and Refactorings and using ML agents. So that's what's going to actually make this thing know what the heck I'm talking about. So that adds that up to the top. And this is now an Academy. We'll probably come in here and edit a few things, but for now, I think we're just going to pull everything out and just leave it empty and save it. We'll switch back to Unity. And on this Academy object here, we're going to add this Pig Academy script. I'm just going to drag it over here. So now, under Pig Academy, you're going to see a broadcast hub. Add brain to broadcast hub. We want to do that. So the brain we want to add is the brain that we just created. I'll click this little circle, and there's a lot going on in here, but we can isolate it with pig brain. So I typed in pig brain player. Perfect, that's what we want. And I believe that these things are fine for now, and we can save the scene. Now that we have the Pig Academy set up, we need to create another script called Pig Agent. And open that up as well. It switched over, but it didn't actually open it. So just search for it here. Pig Agent. Yep. So we're going to open that up. And this is going to need to inherit from agent. Okay, and again, this is going to require using ML agents. And the agent we will close as well. And let's just go back to Unity really quick to see what this looks like. So we need to actually open up this pig again. We're going to open up use this little arrow to open the prefab. And then this pig needs to have the pig agent script attached to it. And this is where we're able to specify the brain that it's going to use and the max step and decision frequency, all these things. Probably able to leave it untouched for now. And I do know that we're going to need to add a rigid body to this as well. So this rigid body is what's going to allow us to use physics on it. And for mass, I'm just going to say 50 kilograms. I have no idea how much pig weighs. One last thing before we finish up the pig. Back in here, we need to actually set this up, I believe, to use the pig brain. So I'm going to make sure that this is set up to run with pig brain. So I'm going to show you really quick how the pig agent ties into the actual player brain. And in fact, all brains. But here's how it works. So public override, and what that's going to do is pull up a list of different functions we can override from agent. In this case, we want to override the agent action function. So I'll do that. Agent action is going to pull a list of actions that have been sent in by the brain, and it's going to do something with it. So in this case, the pig will eventually move. There's nothing that has to be done in agent action, the base class, but I'm going to leave it in because it's just decent practice. So what we're going to do, let's check what the value of this is. So if vector action, and then what do we want to check? We want to check the first branch, so 0. Remember, that's moving forward or backward. And we want to check to see if that is 1. Because remember, a value of 1 meant that we wanted to move forward. So when we press W, it should trigger this. And then here, I'm just going to do a log statement, and I'm going to say forward. Save that. And when I go back to the project, if I hit play, what should happen in the console, if I press W, oh, there we go. Took a second there. But it's heading forward. So that's exactly what we want it to be doing. And the code going forward is going to tie in just like that. Now that we've created the Pig Academy and the Pig Agent, we need one more. And we're going to create another C# script. And this is the pig area. And the pig area is what is actually going to set up the stumps and the truffles and everything that's going to be put around in this space. So we'll open that up in Visual Studio. We need to inherit from area, and we'll do the quick actions again using ML agents, and then we can remove this for now. I have done a fair amount of coding at this point, filling in these code files that we added, the pig area, the pig agent, and the pig academy. And I wanted to do a little walkthrough rather than type it out and have you watch me code and follow along. I figured I'd provide the code, and then you can just, I'll do the quick walkthrough, and then you can understand it on your own. So the first thing that happens in the pig area is that it's going to start up and it's going to grab a couple things. It's going to grab the ground renderer. Reason being, we're going to change out the ground material to show green when the pig succeeds at its task of collecting all the truffles, and red when it fails. So we need the ground renderer and the ground material. And then we're also going to need this layer mask later, not ground. It's basically a mask that says it looks for collisions, and it just looks for a collision that's not with the ground. But we'll get to that in a second. This code is pretty straightforward. We have something that's overriding the base class, the reset area function. And all we're doing here is we're resetting the agent, we're resetting the truffles, and we're resetting the stumps. So we're going to place them randomly around the environment and make sure that they don't overlap with each other. I'm going to skip over this for just a second, and I'll come back to it. So resetting the truffles, resetting the stumps, that's pretty straightforward. All we're doing is we're going to clean up the old ones here. We're going to create new ones, and we're going to use this function randomly place object. I hit F12 there to go to the definition. It's still in pig area. So randomly place object, what it does is it actually first turns off the collider that's on it so that it makes sure it's not colliding with itself and that we're not going to test this the wrong way. But what we do is we get a radius around the object, and this is a method that I also defined below. But we get a radius that's about 10% larger than the actual object itself. And then we're going to attempt some number of attempts, maybe 10, and we're going to do a sphere check. And basically what this check sphere does is it checks to make sure that there's within a sphere around a point with a certain radius that it doesn't collide with anything. And so that's how we know that we're going to be able to place something safely. So it generates a random position and a random rotation, and then it just double checks and then tries to find a spot. If it fails to find a spot after that max number of attempts, then it'll log an error and it just won't do it for that round. And then it re-enables the collider. Get collider radius is right here. I'm not going to go into that, but essentially it just finds a radius that's safe around that thing. Back up here, we have get smelly objects. In that case, that is just going to return our list of all of our truffles. We have swap ground material. This is just like in some of the examples that Unity provides. Swap ground material is just going to switch out the material from success material to failure material, or back to the ground material. And it does it for about half a second so that you can visualize this as the pigs are training. Update score, that's another visualization thing that I added. I added a scoreboard to these objects, these training areas. You'll also notice that I added more of them. I'll get to that in a minute. But this will update as the pig trains, as it's getting new rewards. It's going to update this score. Reset agent just randomly places the agent somewhere in the area, and I think that might be it for the area code. Now, in order to make this code work properly, we're going to need to update some tags in our area. So I'm going to go back to Unity. I'm going to open up pig area here, and you'll notice I have several of these. We're going to duplicate these, but for now, we just want to edit this main one, and we want to click into the prefab here and make a few changes. So first change is we need to add tags to the walls. So I'm going to shift select all of these walls and make sure that they have a tag on them. I actually created this already, but there should be a wall in here, wall tag in here already. You'll want to click and select that. If there's not, then you want to add that tag, and then just make sure that you come back here and make sure that they're all changed. So that wall needs to be the same. I also raised the walls here because they're the colliders, not necessarily the visual portion of it, but the collider. I multiplied the Y size by 4 because my pigs were flying out of the arena. And while that was funny, it wasn't very helpful for them to learn. The next thing is, because we're going to be using tags for other things in this that end up in this arena, I'm just going to do that now. So we're going to edit these assets, these prefabs. So we need to edit the stump and the truffle as well and make sure that these have tags. So stump, if we open that prefab, I've added a stump tag, which you will need to do as well. And the truffle has a truffle tag. So all of these things are going to help it so that when it encounters these in the environment, we can make smart decisions in the code. We also need to make sure that the ground in the area has a layer on it. So if you select ground, and actually I'm bad habit here, I need to click into the pig area and make sure I'm updating the prefab instance, or the original prefab. So ground, I've added a layer called ground, and you may need to add that layer. But ground, that's what we're going to use in that check sphere that we were doing here. This check sphere not ground layer mask, what that's doing is up here, is it's looking for that ground layer, and it's making sure that we don't collide with it. The next thing to do with this area before it'll work is add the area script. So I'll remove this, and I'll show you how that looks to clean it up. I'm also going to remove the score text, which I added, so you can see how I'm doing this. So first, add this component. I want to add the area, and specifically the pig area. You'll notice that all these say none. We need to hook these things up. So the pig agent, in this case, is just this pig. So we click it, drag it into here. The ground, same thing, drag it into here. The success material and failure material. By default, it's set to use this white, but we need to have a green and a red material. I've created these materials in a materials folder here. I have success and failure. So if we go back up to this area here, we can drag in the failure material to the failure slot and the success material to the success slot. And just a little preview, you can kind of see if I were to drag that over, that's what it looks like. Now don't let go. You don't want to set that right now, but that's how you'd set that. And then score text. This is something that I added. If you go up here and click create, you can create a 3D object called Text Mesh Pro. And this is where we're going to show the actual score. So first thing, we don't want it to be standing up like this. So rotation, we want it to rotate around the x-axis. So we'll set that to 90. And then you can see that it's kind of doing some Z fighting with this existing spot. So we're going to raise it up by like 0.01 just to make sure that it's above the ground, but not very high. I'm fine with the size of this text, but we do want to make sure that it is centered. So I'll click center. We want to make sure that it's kind of dark so that we can see it. So I'm going to make it kind of just this middle gray here. And then the starter text, I'm just going to make it 0.00 because that's the format that I'm doing this in. Don't put an enter. There we go. And then that should be it for creating the score text. I'm going to rename this to score text. And then back up in this pig area thing, we need to hook that up. So take the score text and drag it into here. These are prefabs that we're going to use. So if we go into the right prefabs folder here, oops, I keep doing that. We want to grab the stump and put it into here, and then the truffle and put it into here. And this is how it knows what to make copies of to place around the environment. Moving on to the pig agent, we have a few things at the beginning of the code file. Move speed, rotation speed, and nostril width. Nostril width is just the space between the two nostrils. I thought that 0.5, so half a meter, while that's way bigger than a pig's actual nostrils, I thought it might be a little bit more pronounced and help for the pig's learning. A few other things in here. These are just references to things that we'll get. So when we initialize the agent, we get these references, we find the objects, and we are able to use these later. Now the first actual interesting code, collect observations. This is all the stuff that the pig is able to observe at any given step. So the first part is this perception, this ray perception, and that's something that we haven't actually added yet. So in the pig, if we go to, now remember, I'm actually in here. I have to click into this pig and open it up. I've already added it here, but basically add component, ray perception. You want to add this to it. I'm not going to add a second one, but this is what's going to actually control or allow it to see things with a raycast. It cannot see truffles, and that's kind of shown right here. So the only things it can see with this ray perception are things tagged stump and wall, and that is why I had to update the tags on the stump and the wall. So that tag, that is what allows us to do this raycasting and allows the pig to actually learn not to run into these things eventually. So ray angles, that just means how many different directions do we want these rays to point out at? Because it can point out at 360 or more if we wanted to, but there's no reason to do that. In my case, I'm just pointing one straight ahead, and that happens to be a 90-degree angle. So that adds that vector observation, which is this perception here. The next one is how we actually detect the truffles. So that's the nostril stereo, which I will get to in a bit, and then the add velocity observation. So the local velocity here that is using within the area, it basically just tells it how fast am I moving in the X and the Z, and that helps it so that it doesn't just keep going way too fast or way too slow. Moving down, the agent action here, this is how it, or where it tells what to do. So it's going to get in this vector action, whether that's coming from us as the holder of the keyboard and giving our inputs, or it's coming from the deep learning portion of things. And in either case, what we do is we have to read in that vector action. So we're going to do rotation first, and you'll see that it's getting that second branch of the action that we defined in the brain, I believe. Brain, this player brain. So this space here, this branches, that's what we're talking about here. This branch 0 is the movement, remember, and then branch 1 is the turn. So that's what we're doing right here, is we're just taking those things in, and then we're applying a rotation that's relative to the space. And then the same thing with the move. We read in the move. The only thing I've done here is I'm moving at half speed to kind of encourage the pig to learn to move forward instead. And apply the movement. We're applying a force, so that's a little different than just applying a speed, because it means it can go pretty fast if it really starts moving forward a lot. But we don't really have to worry too much about this. It'll figure it out as it goes. Then here's where it determines the state and whether it's done or whether it gets a reward. In this case, it's saying if the reward goes below -5, give up and swap out the ground material to show that it failed. Then it resets the area. If that's not the case, then it checks to see if the number of truffles is greater than, or the number of truffles collected is greater than the total number of truffles, if greater than or equal to, obviously. If so, then it's done, success, and it swaps out the ground material and resets the area. And then the third case here is where no success or failure has happened, so we just take away a little bit of reward just for encouraging the pig to move forward and keep moving. And then the update score here is going to call that thing on that method on the scoreboard and get that reward that we have so that we can see it. Agent reset, pretty straightforward. We set the velocity to 0 and we set the number of truffles collected to 0. This get nostril stereo, this is basically taking the distance of every single truffle to each nostril and doing some math on it to determine how strong the smell is in each nostril. On collision enter, we want to determine, is it a truffle? If so, collect the truffle and destroy that truffle. If not, is it a wall that we're colliding with? If so, we're punishing the pig just a little bit. I found that if I punished the pig too much, that it would be too paranoid about hitting the walls, and if I didn't punish it at all, it would just slam into the walls like crazy, just trying to get as many randomly collected truffles as possible. And then the last thing is this collect truffle. All it does is it keeps count of how many have been collected, and it gives itself a point if it collects one, and it updates the scoreboard. Now, back into the editor here, one last thing I want to talk about with the player, or with the pig brain, is this vector observation space. So the space size is set to 8. If you run this and this doesn't match, it's going to warn you. It's going to say, you only said 1 and it was expecting 8. How is this number calculated? So the number is actually calculated based on the number of observations that we create in this collect observations here. So the stereo smell here is only 2. It's 2 floats. This velocity observation is another 2, so we're up to 4. And then this ray perception is also 4. And that's because we have one angle that we're doing that times 2 detectable objects. And for each detectable object, it says either yes, I saw it, or no, I didn't see it, and how far away it is if I do see it. So that's 4 right there. So that's how we get to that 8 number right there. The last code file here is the Pig Academy, and this one's really easy to understand. It has a list of the areas, and as I mentioned, we're going to create more than one area so that it can train in my case, I did 8 areas simultaneously, and all it does is it overrides this Academy reset thing function, and in that case, it finds all the areas, and then it sets all the number of truffles, stumps, and the spawn range to these parameters, which we're going to pull in from a curriculum learning file. And then it resets the area. The curriculum learning file is this. It looks like this, and I'll show you where this comes from in a minute. You're going to create a file here, and I will share this file, of course, that has a set of parameters that we want to set and kind of gradually increase the difficulty as the pig learns and is more successful. So what it does here is it tracks the reward. When the reward is above these thresholds, it'll jump up to the next difficulty. So it's going to start out and the reward is going to be negative. And then eventually, once the reward is consistently high, then it's going to jump to this next difficulty. Those difficulty levels are determined here. The number of truffles, the number of stumps, and the spawn range. So when it starts out, it's only going to spawn 1 truffle, 1 stump, and the range is only going to be 2 meters in every direction, a square. And then when it hits a reward of 0.5, as long as it's had 100 lessons so far since the last jump, it's going to increase that difficulty. So now we have 2 truffles, 2 stumps, and a spawn range of 3. And then we just keep going up. And eventually at the end, it's going to have 15 truffles, 6 stumps, and a spawn range of 12. And since our arena area is about 25 by 25, 12 in each direction works. Now, where does this curriculum file go? It actually goes here. So this is my main project file. This is the one that the GitHub project right in here. There's a config folder. Inside here, there's a curricula folder. And you'll find that there's a few that already exist, wall jump and push block. You'll create a pig folder. And then inside here, you need a pigbrain_learning.json. And that's where that file lives. Then back up here in the config, there's also a trainer config. Trainer config is used by all of the different brains. And it looks like this. There's all these different settings that it sets for telling the neural network how to build itself and how long to run and that sort of thing. So I've added a new section, pigbrain_learning. It has a max steps of 1 times 10 to the 7th. I found that when I did it to the 6th, I wasn't able to leave it for very long and it would just give up. Batch size, buffer size, beta, these are just kind of trial and error in my experience, and I haven't done a ton of trial and error, but these settings seem to work all right. The number of hidden units is basically how complex do you want your brain to be, and the number of layers. You kind of multiply these together and you'll get an idea of how complex they are. If you compare that to this basic learning one, there's only 20 hidden units and 1 layer, so it's not nearly as advanced of a brain. And when we copy that, like originally I tried copying that, my pigs were very dumb. They could not learn much of anything. They would just spin in circles, and I mean, they were somewhat effective, but they could only learn to turn one direction. With this, with more advanced brains, they're able to do a lot more. Before we get to learning, we have to do a couple things. So the first thing is we need to create a new brain. And we go up here into Create ML Agents Learning Brain. We're going to call this Pig Brain Learning. And this just is going to be a machine learning brain, or in this case they call it ML Agents, so machine learning brain. And we're going to copy the brain parameters from our pig brain player. And what that does is it brings over exactly what those parameters were. Remember, we need a space size of 8. I'm actually going to increase this to 10, and what that does is it kind of keeps a history of the last observations, and it allows it to have a sort of memory. If we were loading a model that we had already trained, we would drag it in here, but because we're training, we don't want to do that at this point. We don't even have a trained model to do it with. Now this learning brain needs to be hooked up in two places. One is in the Academy. We will add it to this list. I had it in here. You may have to hit add new to get that slot. And then we're going to check this control box. This basically says that we're going to be able to control it externally from the command line that does the training. And then also the pig. So I'm going to open up the pig prefab, and I'm going to make sure that this brain here is set to learning. I did this previously, but you're going to want to set this to learning, and that's what's going to allow it to actually learn. And the last thing, out back into that pig, I mentioned this previously, but we want the move speed to be 0.9. I found that 1 seemed a little too fast. I set it to 0.5, and it almost seemed like the coefficient of friction was preventing it from getting moving. So this is just a sweet spot. You can experiment with it as you like. When they were going really fast, I even had them just kind of flying out of the arenas and stuff. That's why I had to raise the walls in the first place. But this should get them training just right. Now the last thing we want to do before we start training is create more of these. So I'm going to take this pig area here and I'm going to duplicate it so that we have 8 of these. I'm going to duplicate. Okay, then I'm going to grab 4 of them and I'm going to increase in the Z direction by 30. And then we have to go through and actually edit the rest of these. Let's see if I'm clever about it. Maybe I can do this intentionally. So in the X direction, we want to go 30, and maybe grab these 2 and go 60. Let's make sure that's working. Yep. And then these 2 and go 90. So what this will do is it allows them all to train simultaneously. And the cool thing is they're all using the exact same brain. So what one learns, the others all learn. And as soon as they reset, they get that updated learning. So that's really cool. So I'm going to save this scene, and then we'll move to training. Now we're going to train this thing. What we need to do is get our, in my case, Anaconda prompt ready. If you're not on Windows, then you might be using something different, but follow the Unity documentation to get this set up. It should be exactly the same way that you would train anything else, and I'll include the link to that in the notes for this. But once you get it set up, this is the command that you're going to be running from within that ML Agents project. And the reason you need to be inside this project is you're going to reference that config YAML file that's here. You see it's in this ML Agents config folder. And you're also referencing the curriculum config curricula pig. And those are the 2 things that need to be set up to run this thing. This command ML-agents-learn. You should be able to find this in the documentation. And what you'll do is you'll hit enter. It'll take a sec, but then it's going to tell me it's ready to start by pressing play in the Unity editor. So I'll press play. And you'll see that the pigs are starting to explore. At this stage, they're not smart. They're just making random guesses at what they're doing. And you'll see that as this goes, it's going to tell you a little bit of summary, what step they're on, and what their score is. But we can also see what their score is right here. At first, there's not a lot of intelligence happening here, so they're probably just going to run out of time. But eventually, you're going to see that some of them start learning. They're going to accidentally run over one, and then they're going to say, oh, that worked well. I'm going to start doing that again. So we're starting to see some green here. This means that they're succeeding. And you're going to see green more frequently than the red, most likely, because the red only happens when they get to -5. But they should make some progress pretty quickly, but the way that they do it might be a little unexpected. You'll see that they're kind of whipping around. They do have these ray perceptions on, so they can see the walls, and they can also see the stumps, but they're not actually reacting to that yet. And they're only able to smell these little truffles that are here too. So you'll see that they just kind of eventually learn, and the longer you let this train, the more you'll see that they kind of improve. Now, I've let mine train a few different times, and sometimes it looks really good, and sometimes it just doesn't look good at all. I've had to tweak a lot of parameters to get it working, and I honestly still haven't figured out how to get these things to work just right, but they do clearly improve, and so I call that a victory. I'm gonna keep playing with it. Maybe I'll try and get it. Maybe I'll get them working better. But I would love to know if you do find certain parameters that work better, maybe rewards that work better than others, punishments that work better than others. I found that if I punish them too much for certain things, then they would just kind of give up and not learn, much like a human or animal would. If you punish them too much, they don't know what they're being punished for. And while in this case this is reinforcement learning, they don't know anything, but they won't be able to coordinate or correlate the punishments or rewards properly if they're completely skewed. So one of the things, for example, in the best practices that Unity mentions is to keep the rewards between 0 and 1 or 0 and -1, because if you punish them too much, then they're not really going to learn properly. So experiment with it, and I'll be very curious to know what your results are.